Okay, this topic actually has the most questions on the test. There's 6 questions like this. Okay, so we're going to look at both graphs and tables. What we need, and here's the thing, is the process is actually the same, because if I'm writing an equation, I need 2 pieces of information. I basically need the starting point, right, the y-intercept, so, and then the change, like how is it changing? Okay, now in some cases it's changing and it's linear, in some cases it's changing and it's exponential. If it's linear, what you'll notice is the table is going to be adding or subtracting, the graph is a straight line. Okay, so like the graph, right, obviously it's like easy to like pick out the graph right away. Okay, if it's exponential, the table is going to, the pattern is going to be multiplying or dividing, and the graph is going to be a curve. Okay, either way, we're still going to be looking for the y-intercept, and then we'll be looking for how it's changing. Now, if it's linear, we're going to write an equation that looks like this, where we put the y-intercept right here, and then that whatever's being added or subtracted goes right here. If it's exponential, we're going to put the y-intercept right here, and then however it's changing, whatever's being multiplied or divided is going to be right here. Okay, and remember, sometimes we're dividing, so like divided by 2, but remember my equation has only multiplication. So if I want to divide by 2, I have to multiply by 1/2. If I want to divide by 3, I have to multiply by 1/3. So, okay, so I'm going to do one graph and one table. But what you want to observe here is that I'm just following these steps either way. It doesn't matter whether it's a graph or a table. Okay, so first, like I look at this graph, I see right away it's not linear, it's not a straight line. This is exponential. And for me, what I'm going to do right away when I realize that it's exponential is I'm going to just write my equation so that I'm thinking to myself, okay, this is what my equation looks like. So now first look, I'm looking for the starting point. Okay, so what's my starting point? What's my y-intercept? It's right here. Okay, so already I can write, I'm starting at 6. Okay, now I'm going to multiply by something and take it to the power of x. So now I'm asking myself, how is this 6 changing? And look what's happening. So look, I'm going to follow it down, and I'm going to come to where x is 1. And look, notice I'm actually would do the same in the table, right? I'm like starting where the x value is 0, which is right here, right? And then I'm going to where the x value is 1. So it's going to be the same kind of observation. But here I'm noticing, oh, this goes from 6 down to 2. And then it goes down to a fraction. This fraction is actually 2/3, right? But notice what's happening when I'm going from 6 to 2. And I know if it's exponential that I'm not subtracting. I'm not doing -4, right? Because it's exponential. So we know that that's going to be multiplying and dividing. So 6, here's what I'm asking myself. 6 divided by what, right? I know it's dividing because it's getting smaller. 6 divided by what is 2? And this number is 3, right? This number is 3. So that's the question I'm asking myself. I realize, oh, I'm dividing by 3. I'm dividing by 3. What is dividing by 3 equal to? It's equal to multiplying by 1/3. So I'm going to put my 1/3 here. This is my equation for this graph. Okay, and if it was a table, right, what would it look like? It would look like, the table would look like this. It would look like 0, 6, 1, 2, right? And then past that there would be a fraction, right? There would be 2/3 here. And then above it, there would be an 18 up here, but it doesn't matter. I can actually just kind of see from that one jump what's happening. Let's look at a table. Okay, it's the same. Right away, I'm going to look and see what's the pattern. And I say, okay, I notice the numbers are getting smaller. So am I dividing or am I subtracting? Let's see. If I'm going, oh, well, I'm not dividing because 13 is prime. So this is actually, I'm going to observe the pattern. This is -11. And you can use your calculator, right? You can say, okay, 13 minus what is 2, right? You could do this. You could do 13 minus 2 and say, oh, the difference is 11 there. So if I do 13 minus 11, I get 2. And then if I do minus 11 again, I get, if I do 2 minus 11, right, then I get -9. Okay, so I can see I'm subtracting 11. So if I am subtracting, then my equation is linear. And it's going to be this, y equals mx plus b. But still, I'm going to start with the b. Now remember that b is right here. Okay, where the x value is 0, that's my b. So I'm going to write y equals, look, I'm going to leave myself a space, okay, mx, and then I'm going to put plus 2. Now this m, this is how is it changing? What's being added or subtracted? And I already realized I'm subtracting 11. So this is my change. That's my equation, okay? So again, when you come down here, okay, observe the pattern first, but listen, whether it's a graph or a table, what you're observing is what kind of change is it? Here's the equation. Find your start, find how it's changing.